All right, freshman physical science. Today we're going to be talking about Newton's third law. This is, of course, action-reaction. We're going to try to tie into net force a little bit there and try to tie in these two sections. We'll bring in a little bit of section one, which was, of course, inertia, and friction. So that will be tied in here. But we're going to be talking mainly about interactions between two objects. Of course, the forces that they apply to each other. This is called action-reaction. All right, so Newton's third law, simply stated, is for every action there is an equal and opposite reaction. Straightforward. If I push on the wall is actually pushing back on me. As I stand on the earth is actually pushing back on me. As I jump away from the earth is actually jumping away from me. For every action, there's an equal and opposite reaction. So, according to Newton, whenever objects A and B interact with each other, they exert forces upon each other. So when you sit in a chair, your body will exert a downward force on the chair, and the chair will exert an upward force on you. This is, again, the idea of net force that we talked about yesterday. Since you are sitting in your chair, there are resulting forces, a resulting interaction. A force on the chair and a force on your body. These two forces are called action reaction. Again, like we talked about yesterday, net force, since you are not moving, there is a net force of zero. There's an equal force being applied downward, gravity, and by the chair, a normal force upwards. This is what we would call a zero force or zero net force. Now, consider the propulsion of a fish through water. As a fish uses its fin, it will push the water backwards. The water molecules will in turn push it forwards. It's kind of a nice little interaction. You have the same interaction with yourself as you swim through water. Okay, as you push yourself backwards with the water, as you stroke through the water is actually pressing on your hand and propelling you forward. You have to fight fluid friction, of course, but that's the idea. So the harder you swim, the harder you swim, that increases your force. So the harder I swim, the more I'm going to be propelled forward. Now, as birds fly through the air, as helicopters fly through the air, they have to use Newton's third law. And as they push down on the air will push up on them. So consider the flying motion of birds. A bird will fly using its wings, will push downwards. In turn, the air will push them upwards. So even the size of their force matters. If they flap their wings harder, they will go higher in the air. If they flap their wings just a little bit, they will probably coast and stay at the same height, or just change their height just a little bit, or even drop depending on how hard they're actually pumping their arms. So the size of the force will determine how high in the air they will go, and what their change in motion will actually end up being. So the action-reaction force pairs will make it possible for birds to fly. So Newton's third law is found in several different places. Okay, here's a nice picture of some birds flying again, using Newton's third law to stay aloft in the air. Again, for other examples of Newton's third law, we have the baseball idea. Of course, when the bat makes contact with the ball, even though it looks different, even though the bat stays in the player's hand, it doesn't go flying backwards, and even though the ball may go over the fence for some of us that were good enough to hit home runs, and that's all based on effort sometimes too, but that particular moment, that moment of contact, is a equal force reaction. So as the ball meets the bat, there's an equal force and an equal and opposite reaction at the moment of contact between the bat and the ball. Even when you're driving, even driving to school, you are able to apply a force with your tire. So as the tire spins downward and it meets the concrete, it's going to press backwards on the concrete. So at that interaction, as that tire meets the concrete and pushes backwards, the concrete's going to exert a force forwards on the car. So you're going to push downwards, and the car is going to be propelled forwards by the concrete. Okay, again, it has to overcome, that's that rolling friction. So that's another instance where rolling friction is a good thing because it helps push your car forward. Again, rockets can use that same idea. As it ignites its fuel in its fuel tank, that fuel shoots out because of high pressure, and it shoots backwards. As it does that, the air molecules outside start pushing the rocket upwards. So as I press the molecules down and out of the rocket, it presses upwards. So that is all we're going to talk about with Newton's third law. It's a fairly easy concept, very similar to net force. Please make sure that you get the worksheet done that is being assigned to you by Mr. Tenniger, and make sure that is done by Monday. Have a great weekend, kids. Thanks.